Let's continue with our journey through radical expressions. This time we're going to multiply and divide them. Now, multiplying and dividing, uh, it's a little bit different than adding and subtracting, obviously. But part of it is you don't have to have the same radicand in order to multiply and divide. That's something that you only need when you add and subtract. So as we take a look at number one right here, on a lot of times on tests, students just forget. They look at this and they think, oh, hey, look, they don't have the same radicand. Let me work on that, and then that's how you get in trouble. Okay, so you don't want to do that. We can go about this two different ways. Now, when we do multiply, we can multiply the radicands together. Okay, that's all you multiply together. You multiply the coefficients together and then the radicands together. Now, we have a coefficient of 3, we have a coefficient of 1 right there. So, as I said, there's two ways to go about this. Maybe using the smaller numbers where we simplify first and then multiply things together might be easier, because a lot of you, if you try multiplying these big numbers together, you're not always very familiar with some of your perfect square factors and then trying to simplify it. So actually, let's show both ways. So first off, what I could do right here with this 12, we could write by two perfect square factors. We have 4 and 3, right? So this right here can simplify down to 2 rad 3. And the 2 multiplied with the 3, that gets us 6 rad 3 right there. And there's nothing we could really do with radical 6. There's no square root. There are no perfect factors that work. So now that we're at this stage, we can go ahead and multiply the two terms together, and you will end up with 6 rad 18. Looks good, but don't forget, you might need to simplify this some more. So let's take a look at that rad 18. Think, what are some perfect square factors of that? I'll put that over right here to the side, and we could have rad 9 times 2, right? Because I could take the square root of 9, that's 3, and then we still have the 2. All right, so that 3 and 6 multiply to get us 18. So we'll now have 18 rad 2 as your simplified answer. So we started simplifying first to try to help us out in our process. Like I said, that's not the only way to do it. Let's see how we could do it. What's the second method? So the second method, you can just straight multiply it out together. So take 12 times 6, and that right there is 72. So what I have is 3 rad 72. We're not even close to our answer that we actually have, because you have to simplify. So this is where things get, it gets tricky. You got to think, well, what are some perfect square factors here that work out? Some of you may start off with 9 and 9 times 8, which works. But you're going to have to simplify it again. So it might be, that's where I'm saying it's easier to sometimes do it the first method, where we simplify smaller numbers together, and then you don't have to worry about, you'll see numbers that you recognize a lot easier. If not, you got to go through the process of saying, all right, well, what are some perfect square factors of 72? I mentioned 9 and 8, which works, but you're going to have to reduce it again. So what else is there? How about 36 times 2? So the square root of 36 is 6. That 6 we multiply with the 3, and that's where we get the 18 times 2 right there. And we get it again. Okay? So either way you do it works, but that's where we practice. Okay? So we take a look at number 2. We got a few problems here. Some new things that do show up. Now, you could take the square root of exponents, because when we talk about the square root, we're saying that this right here is the second root. When you raise a power to a power, you're multiplying. This second root, when we talk about the square root right here, let's say if we said the square root of x, that is actually the same thing as x to the 1/2 power. Okay? Or what we're taking the radical by is your denominator, and inside of the radical where that x is to the first power. So that's where we get the 1/2. It's just like a conversion. Okay, so you might want to look that up a little bit more if you didn't get it, or if you need more practice with that. So right here, if I take a look, there's nothing I could do. I can't take the square root of 15. I can take the square root of n squared. But actually, let's multiply the two together. Okay, so if I multiply the two together, the two terms, 10 times 100 or 15 times 100 is 150. Okay, so we have that part right there. N squared times n to the third. When you're multiplying exponents, you add the powers together. Okay, very important thing from algebra. So this becomes n to the fifth. So there's a lot of moving pieces that you guys have to remember now. Okay, so we got to think, well, how could what are some perfect square factors of 150? We could try 15 and 10. That doesn't really work, right? What else can we have? How about 25 and 6? 25 times 6 right there, that'll get us our 150. And then we can't take the square root of odd exponents, okay? That's something that you need to know. You can't take, once again, you can't take the square root of odd exponents, okay? So what I have to do right here with this n is we're going to go ahead and split this up. Just kind of like what we did with the 25 and 6, right? We found different factors. And so what I can do is let's go ahead and change this to n to the fourth times n. What we can take the square root of are even exponents. And what happens is you take your exponent and you divide it by 2. Because why? Think about what happened right there. We got x to the 1/2 power. So let's go ahead and simplify this all the way out. The square root of 25 is 5. Okay, so that's going on the outside. I'll go ahead and put this right here. The square root of 6, can't do it, so that's going to stay on the inside. Now we take a look at n to the fourth. Okay, if I take the square root of n to the fourth, you take the power, divide it by 2, and so 4 divided by 2 is 2, so we now have n to the second. And what's left inside is the n now. And that is the simplified version of what we have here. If you find that you have a lot of difficulty with this, make sure you come to office hours and we can work that out together. Okay. We take a look next up at number 3. Let's go ahead. Remember, the coefficients we can multiply. So that right there will get us positive 18. Let's go ahead. We'll multiply the radicands together. And remember, it doesn't matter if they're the same or not because we're multiplying. So we have 7 times 7. That's 49. And we have r to the third times r squared. Now, like I said, it's multiplying, but when you multiply exponents, you add the powers. So this right here becomes r to the fifth, not r to the sixth. So let's simplify things right here together. We can take the square root of 49. Okay, so that works out nicely. So that'll be 7. So we'll end up taking 18 times 7 right here, and that'll get us 126. And then remember, with this r to the fifth, I cannot take the square root of r to the fifth. So I'll go ahead and split it up where it's r to the fourth times r. because I could take the square root of an even exponent, and then remember what we'll do is divide it by 2, and so now this will become 126 r to the second square root of r. And there is your simplified answer right there. All right. On number 4 right here, it's pretty much you're distributing, okay? So you'll start off, take the square root of 3v times rad 6, and then so that'll become the square root of 18v. And then we'll distribute that 3v again, and we end up with rad 30v. So at this point in time, you got to make sure we can't add them together, right? Because once again, they don't have the same radicand. So let's see if we can simplify this any further though. Perfect square factors of 18. How about 9 and 2? The square root of 9 is 3, so this becomes 3 times the square root of 2v. Go back to 30. Perfect square factors of 30, if there are any. We could do 3 and 10, but that's not a perfect square. We have 30 and 1. That doesn't help us. 15 and 2. Can't take the square root of 15. So let's go ahead. Let's think if there's any others. 6 and 5. I can't take the square root of 6 or 5. So this right here, the best bet would be the square root of 30v. Okay. There it is. There you have it. Number 5. You take it one step, take it up a notch. This one right here, we have two binomials. You're going to have to FOIL this out. So let's go ahead and start that. Negative 2 rad 3 times rad 3. Negative 2 times rad 9. Now remember, when you multiply the radical twice by itself, it actually ends up being that number. Meaning rad 3 times rad 3 is equal to 3. Because think about it. What I did right here is I turned it into rad 9. But what is the square root of 9? 3. So I could avoid this one step, but I'll just go ahead and put that down for now. So there's the first terms. Next up, let's go to the outer. We have negative, or actually negative times negative is a positive, so positive 10 rad 3. And then the inner is going to be plus 2 rad 3, and then the last is minus 10. So we'll go ahead, we have that right there. We can combine a few things together. That we definitely can combine. So that will get us to 12 rad 3. Now remember, square root of 9 is 3. So 3 times negative 2 will get us negative 6. So we go ahead and put all this together. Negative 6 minus 10. We'll have negative 16 plus 12 rad 3 as your solution. All right, and there's the simplified answer. Now there are more nuances when it comes to multiplying and dividing radical expressions. So we'll have to get to that right here. So now when we multiply and divide, when we take a look at this example right here, we can't leave an answer that way. Why? I don't know. It's one of the rules. We can't have a radical in our denominator. So I'm sure we've talked about this a lot. And hopefully you remember this term, rationalize the denominator. Okay, in order to rationalize the denominator, the easiest thing is to look at whatever the denominator is and multiply it by what you see there. So multiply top and bottom by rad 3. So if we multiply top and bottom by rad 3, what I care about is making sure that the denominator becomes a whole number. We just looked at right now, we said rad 3 times rad 3 ends up being the exact same number because it turns into rad 9, which turns into 3. In our numerator, we end up with rad 12. That's 4 times 3. Now, you should know, I never make things easy because you're going to have to simplify. So if you're saying, well, oh, we're done. No, 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 no. You better go back and check yourself. All right. So right here on 12, what are some perfect square factors? 4 times 3. The square root of 4 is 2. And then we end up with rad 3 over 3. Now we have our answer simplified. So rationalizing the denominator is absolutely critical right here. Okay, it is an important piece to being able to solve problems out. Okay, in algebra 2. In the second problem, we got ourselves 5 rad 20 in our denominator. So I did say, hey, the easiest thing to do is to multiply it by itself. Okay, so I can multiply this by 5 rad 20, but we have a very big number. Another thing that we could do right here is take our denominator and think, okay, is there a number that I could multiply it by, like multiply the radical by, where it becomes a perfect square? So the thing is, if I take rad 20 and I multiply it by some other radical, can I get a perfect squared factor? I'll let you think about that. Because the next step is we're still rationalizing. But what I'm going to do right here is multiply this by the square root of 5, top and bottom. And that's how I'm going to rationalize this. Because now 20 times 5 is 100. So I got 5 times rad 100 in my denominator. In your numerator, we got 15 times 5, and that becomes 75. And then let's go ahead and simplify everything. Rad 10, or square root of 100, that ends up equaling 10. So we take the 10, we multiply it by 5, we get 50. And 75 in my numerator. So after all that's said and done, let's go ahead and simplify it. We could divide top and bottom by 25. You should have 3 halves as your answer. Let's move along. Now, the last type of problem you'll see right here is where we're going to have to do this next step, what we call multiply by the conjugate. Right here, because I have 2 terms in my denominator, you cannot just rationalize. It doesn't work out that way. So the conjugate is when you take that term and you will take the middle and take the opposite of that. So meaning in between these 2 terms is a plus sign. The conjugate will be 4 minus 4 rad 5. Okay. And we'll multiply top and bottom with that right there. 4 minus 4 rad 5. It works out nicely because when you multiply by the conjugate, I have 2 binomials, so you're going to FOIL things out. The trick here is this. If you multiply it correctly by the conjugate, the outer and inner terms cancel out. So all you really have to worry about is multiplying the first term and the last terms together. Okay, the outer and inner cancel out. You're saying, how does that happen? Well, let's take a look. If I take 4 times 4, it's 16. The outer terms is minus 16 rad 5. The inner terms, these 2 now, that becomes plus 4 rad 5. Or sorry, plus 16 rad 5. And then the last term right here, is going to be minus 16 rad 25. And I could simplify that later. But look what happens here. You see how this, like I said, the outer and inner terms cancel. So all you really need to worry about are the first and last terms. So let's go ahead. Let's say I didn't do all this foiling. I just multiplied the first. That's 16. The last terms, once again, when I multiply, it's 16 rad 25. And we need to simplify that. The square root of 25 is 5. So let's take negative 16 and multiply that by 5. And we now end up with negative 80. Right, so this becomes negative 80 right here. And so 16 minus 80 and you got negative 64. Now we haven't even bothered touching the numerator yet. All you need to do up in the numerator is make sure you go ahead and distribute. So 3 times 4 is 12, and we got ourselves minus 12 rad 5. Okay, so we got 12 minus 12 rad 5. Another nuance to mathematics is that we normally don't like to have the negative in the denominator. So what you could do is bring it up to the numerator, or you could put it up onto the side right here. If you put it to the side and then you put 12 minus 12 rad 5 over 64, that looks a little bit better. But if you don't want the negative, what you could do is you bring it to the side and then you distribute it out. And what you'll notice is that your answer will be negative 12 plus 12 rad 5 over 64. And this may be a more acceptable answer later on in the future. Okay, so both of these are the same. It all depends on how the format is. What we normally don't want is this one right here. Okay, we do not want a radical in our denominator. And that right there is multiplying by the conjugate. Okay, and so you've seen all the different methods necessary in order to scenarios that you'll deal with radical expressions. Make sure you know how to rationalize and multiply by the conjugate. So if you had difficulty with those, you might want to go look on Khan Academy to refresh your memory on those types of multiplying radical expressions. All right, and that concludes this part right here.